If you have not clicked the subscribe button till now, please do it right now, and click the bell shaped icon also, so that you can keep on getting all the notifications of these useful uploads on this amazing channel. So let's get started and have the first amazing fact. The first amazing fact relates to, I think this is the most common one and most of us already know this. This is when you have to add or sum up the first n natural numbers. First n natural numbers. Like suppose somebody asks you, what is the sum of 1 plus 2 plus 3 plus up to say 400? Oh my god, you can't keep on adding them, right? So this number is n, right? Up to n. Just use the direct formula n multiplied by its successor, that is n plus 1, and divide the result by 2. So what will be the answer here? N is 400, so multiply that by 401 and divide the result by 2. So 2 cancels this 200 times, and your answer for the question will be double of 401, which is 802 followed by 2 zeros. Now no need to add the natural numbers, you get the answer directly. Now this is one of the simplest things, right? The second fact onwards, you will realize there are so many different things to learn. Now let's expand this and do the second one. Now I want to take only the sum of first n, not natural numbers but selected band of natural numbers which are even numbers. Now when you have to take only the even numbers, there is a slight change in the formula. This upon 2 vanishes and you have to do only n times n plus 1. Now suppose for the same question I need to do the sum of first 400 even numbers, 2, 4, 6, 8 up to 400 such even numbers, first 400 such even numbers. Then I'll put 400 here, 400 times 401, that will give me my answer. And likewise the third one, let's complete this part, the sum of first n odd natural numbers. So we have a formula for everything, and odd numbers is even more simpler than even numbers. If you are selecting n odd numbers, just do n square. Pretty easy, right? Let's take an example of this one. So suppose I need to do 1 plus 3 plus 5, all odd numbers. Up to how many such odd numbers? Maybe let's take 21 numbers. 21 such numbers, okay? Starting from 1, we are taking odd numbers, and how many numbers? 21 numbers. So the sum will be 21 square, which is 441. You don't have to do any calculation, just do 1 square and you get your answer. So 3 basic tricks which will help you in cracking so many different types of questions in the quant exams. Let's move on to the next type. The fourth amazing series concept is based on sum of, now again we are adding something, sum of, this time I am taking the squares of first n natural numbers. Now the same thing, but this time I want to add the squares. So what is the example? Like I have to do 1 square plus 2 square plus 3 square up to 10 square. Okay. Now I want to find the result. So if this number is n, that is 10 in this case, I just have to do n, its consecutive number n plus 1, and then twice of n plus 1 and divide the result by 6. I'll get my sum directly. I don't have to find the squares of the individual numbers. I just have to put the value of n. So what happens here? N is 10. So 10 plus 1, 11, and double of 10 is 20 plus 1, 21, and divide the result by 6. So 3 2s are 6 and 3 7s are 21. 2 cancels this 5 times, and so what is this? 55 into 7, and that is 350 plus 35, 385 is the sum of squares of first 10 natural numbers. Isn't that amazing? One formula and you get the squares, the sum of squares of any number of natural numbers. Now expand this to the fifth amazing fact. Now I want to take the sum of squares of first n. Now I'll split it. Now I want to take only the odd natural numbers. Now this is important. Now up to fourth, I think many of us know the trick, but after fourth, they are rare. Sum of squares of first n odd natural numbers. Now when we have to take the odd natural numbers, you have to do n times 4n square minus 1 and divide the result by 3. So you can check. You can take like 1 square plus 2 square plus 3 square only up to say 3 square. Okay, but that will go in the fourth trick. For the fifth trick, you have to do 1 square plus 3 square plus 5 square plus 7 square. So you can take first 4 odd natural numbers and we are trying to add the squares. Just put n equal to 4, you will get your answer. I leave the trial part for you, okay, so that we don't unnecessarily elongate the video. Okay, let's have the sixth fact. Now the same thing with sum of squares of first n even natural numbers. So very interesting. Even natural numbers have a different formula than odd natural numbers. In this case, you have to write the same thing. All the factors here, they remain the same. n plus 1, 2n plus 1. Just have to multiply this by 2 and divide the result by 3. You get the sum of squares of first n even natural numbers. So I can take an example. Let's take 2 square plus 4 square plus 6 square. Okay, I want to take only 3. I want to find the squares using this formula. So twice of n. What is n? 1, 2, 3. So 3 times 3 plus 1 4 times 3 times 2 is 6, 6 plus 1 7 and divide the result by 3. So 3 cancels out and you have 7 4s are 28, 2s are 56 as the answer. Can we verify? This is 4, this is 16 and this is 36 and just add these three. You will be surprised. Your answer is 56. Likewise, you have a trick for everything. You know, quantitative aptitude is all about smartness and knowing these things. If you don't know these things, you will be, following those long traditional methods which will consume and, eat up so much of time that you will be, you will not be able to complete the paper within time. Okay, let's see the next one. The seventh one for the video. So now I want to enter into cubes. Now if I have to do sum of cubes of first n natural numbers, again the same thing, but this time I am taking the cubes. So just like 1 cube plus 2 cube plus 3 cube plus up to say I have to do 10 cube. Okay. Very big if you want to calculate, because most of the students, they don't know the cubes up to say 20 also. If I ask you what is the cube of 14, you are going to fumble. Cube of 17, cube of 18, very difficult. Okay, so just use n into n plus 1 by 2, that is the sum of the first n natural numbers formula, and take the square of this. You will get the sum of cubes of first n natural numbers. Okay, so what will be the answer here? So here n is 10, so 10 into 11 by 2 whole square, that will give me 55 square, and my answer will be 5 6 are 30, so 3025 will be my answer. So if I add the cubes of first 10 natural numbers, I'll get 3025 as the answer. That's quick, right? Okay, 2 more tricks coming up here for this, and then we have 2 more amazing tricks. Okay, right, so the 8th one. Now I want to find the sum of cubes of, now obviously I have to split these natural numbers into even and odd. Sum of cubes of first n even natural numbers. And the same thing for the 9th one, I will have sum of cubes of first n odd natural numbers. Okay, odd natural numbers. Now these two formulas, I have written them together. There is a reason for that, because the formulas are little bit confusing, because when you do both the formulas at the same time, it will be little bit consuming. time consuming. Okay, n and n plus 1, just do the squares, n square and n plus 1 whole square. Now I'm telling you how to remember the formula. Okay, and just do twice of this, you will get the sum of cubes of first n even natural number. So if I have to do 2 cube plus 4 cube plus 6 cube up to 10 cube. Okay, so 5 numbers, I can put n equal to 5 here and I'll get my answer directly. Okay, like so you can do this. Okay, I'll leave it to you as a DIY. Then sum of cubes of first and odd natural numbers is little confusing because it interferes with this formula. So you have to do n square in both of them, and apart from that you have another term 2n square minus 1 in case of odd natural numbers whose cubes are to be added. So these are some of the basic things we should know if we want to find the cubes, sum of cubes of the natural numbers, then even natural numbers, and then the odd natural numbers. So these are 9 things, and the 10th one and the 11th one, they are the most amazing ones. Let's see the 10th one for this video. Now in the 10th one, we have a divisibility rule. Suppose I have n cube minus n, like say 18 cube minus 18, or I have n raised to power 5 minus n, or I may have n raised to power 11 minus n, or for that matter n raised to power 13 minus n. Now these 4 rules are very, very important for competitive exams because you get so many questions based on these. Now these expressions which I have written have a unique power. Here we have cube, here we have power 5, power 11, power 13. Actually, when you take n cube minus n, it is always divisible by 3. Now you can check. If I do 2 cube minus 2, 2 cube is 8, 8 minus 2 is 6. Yes, it is divisible by 3. Every time n cube minus n will be a multiple of 3, or it will be divisible by 3. Likewise, we have a power 5 here, right? So this will always be divisible by 5. This will always be divisible by, the power is 11, so divisible by 11. And here the power is 13, so it will always be divisible by 13. Now, a very, very important concept in quant, and you get so many multiple choice questions. They will give you an expression like this and ask you by which number is this divisible. So you can't calculate 2 raised to power 11 even. That is also difficult in a quant exam. It will take so much of time. And what if you get a number like the 17 here, 17 raised to power 11 minus 17. Oh, very difficult to find, and it will be divisible by 11. So the powers 3, 5, 11, 13, they are special powers if you want to remember these rules. Okay, and the final one, 11. Now suppose there are 2 numbers whose ratio is known. Okay, I'll take an example also, very important. So suppose the 2 numbers, the ratio is A ratio B. Okay, and the LCM of these numbers A and B is say X. Okay, I can actually find the HCF of A and B. How? Just take X, the LCM, and divide it by the product of the 2 terms of the ratio A and B. You will get the HCF. Very important concept for quant exam. Okay, now let's take an example. Suppose we have the numbers 28 and 42. Okay, now what is the ratio of 28 and 42? The question will be given in this form. The ratio of 2 numbers is 14, 2, 14, 3. So 2 ratio 3, right? And this is given to us, the ratio of the numbers, and we are given that the LCM of the numbers is 84. LCM is 84. Now using these 2, we have to find the HCF of the numbers. So what will be my answer? Just take the LCM and divide it by the product of these 2. 2 into 3. So 6, right? And 6 cancels this 14 times. Yeah. So the HCF of the required numbers is 14. So you don't have to find the numbers. I took this as an example and I framed the question and I got my answer. HCF is 14. You can check. 14 2s are 28. 14 3s are 42. So HCF is indeed 14.